Welcome to MRL. This is the second part of answering the questions of different pages of the topic Power Play of Ganita Prakash 8th grade maths textbook. In the first part we have answered the questions from page 22 to 32. Now here we'll be answering from page 32 to page 45. So let us start with the page number 32 now, the question number 26. Now express the numbers in standard form. We are given the number 59,853. We have to write in standard form, that is k into 10 raised to n form. Therefore we have 5.9853. So 1, 2, 3, 4 into 10 raised to 4. 65,950 can be written as 6.5950 into 10 raised to 4. Then we have got here, we can write it in the standard form, putting the decimal point at after 3.43. I can take it as 3.43. 1, 2, 3, 4, 5, 6 into 10 raised to 6. Now here this number can be written as after 7. So 7.004 into 10 raised to 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 raised to 10. So these are the standard forms or the scientific notation of the given numbers, that is in the standard form. Now question number 27 is page 38. On page number 38, question number 27, the global human population is 8 into 10 raised to 9 and African elephants are 4 into 10 raised to 5. Now we have to find the ratio of the two populations. So the population of human is given and African elephants population is known. So we have to find the ratio of the two population. So the ratio will be 8 into 10 raised to 9 divided by 4 into 10 raised to 5, and that is 2 into 10 raised to 9 minus 5, 10 raised to 9 minus 5, that is 2 into 10 raised to 4, and the answer is 20,000. Therefore the ratio of the human population to African elephant is 20,000:1. So remember that. Now coming to the next example, that is question number 28, page 38. To find the number of ants for every human in the world. The population of human is 8 into 10 raised to 9, almost 8 billions or 8.2 billions approximately. The population of ants is 2 into 10 raised to 16. Now we have to find the number of ants for every human being. So we have to divide the number of ants by the number of the population of human beings, that is 2 into 10 raised to 16 divided by 8 into 10 raised to 9, and since we have 10 raised to 16 divided by 10, we can subtract 16 minus 9, and 1 by 4 into 10 raised to 16 minus 9, and 1 by 4 becomes 100 by 4. I can take 2 zeros. Please understand, here I have taken 2 zeros from here, so it becomes 16 minus 9 becomes is 7. When I take 2 zeros it becomes 5, and therefore 100 by 4 is 25 into 10 raised to 5, and there is 2.5 into 10 raised to 6 ants per human being. So please remember that. Now the global population of starlings is 1.3 billion, and that is 1.3 into 10 raised to 9 starlings. The starlings in one flock are 10,000, that is 10 raised to 4. We have to find the number of flocks of starlings in the world. So divide 1.3 into 10 raised to 9, that is billion, 1. Okay, so many starlings divided by the number of starlings per flock. Therefore it will be 1.3 into 10 raised to 9 minus 4, that will be 1.3 into 10 raised to 5 flocks. So these are the examples, calculations of what you call exponential notations: addition, subtraction, multiplication and division. Now let us go further. The number of trees globally are 3 trillion, that is 3 into 10 raised to 12 trees, and the number of leaves in each tree are 10 raised to 4 leaves. Then we have to find the number of leaves in all the trees. That is 3 into 10 raised to 12 into 10 raised to 4 becomes 3 into 10 raised to 12 plus 4, that is 3 into 10 raised to 16 leaves globally. Now the thickness of a sheet of paper is given as 0.001 centimeter, and the distance between Earth and Moon is so many kilometers. Okay, remember that, 3,84,400 kilometers. To find the number of sheets stacked to reach Moon. Now a number of sheets is equal to number of sheets will be equal to the distance between Earth and Moon, so many kilometers. But remember here the sheet thickness is given in centimeters, we have to convert it to kilometers. So it will be 0.001 into 10 raised to minus 5 kilometers, and then by dividing we get 384,400 divided by 1 into 10 raised to minus 8, removing the decimal point here in the denominator. Then we get 3.84, because I have to write it in standard form. 3.84 into 3.84400 into 10 raised to 5, because 1, 2, 3, 4, 5, 5 decimal places, 5 places after the decimal point is placed after 5 places, therefore it is 10 raised to 5 into 10 raised to minus 8 becomes plus 8, because 1 by a raised to minus n is equal to a raised to n, so 10 raised to 8. So adding we get 3.84400 into 10 raised to 13 sheets. So that is so many sheets have to be stacked to reach from Earth to Moon. So that is the answer for that. Now one star is counted every second. The number of stars in the universe are approximately 2 into 10 raised to 23. Therefore the number of seconds required are 2 into 10 raised to 23 into 1 second, that is 2 into 10 raised to 23 seconds. That is the answer. Now time for drinking 1 glass of water or 200 ml of water is 10 seconds. The time taken to consume water on the planet Earth, that is water on Earth is approximately 2 into 10 raised to 25 drops, and therefore 2 into 10 raised to 25 drops have to be divided by 16 first, because 1 milliliter of water is 16 drops, but we have 200 ml of water makes 1 glass of water, that is 1 glass of water. So when I divide by 200, again I get a number of glasses of water. So it is 2 into 10 raised to 25 divided by 16 into 200, so many glasses of water. Now 2 into 10 raised to 25 divided by is into the time taken for 1 glass of water. For 1 glass of water the time taken is how much? 10 seconds. So I have to multiply by 10 here. So it becomes 2 by 16 into 10 raised to 25 divided by 200 into 10. That becomes 10 raised to 25. So you have divided here. 2 ones are 2, hundreds are. So 10 raised to 25. Here is 1 0, therefore I have added 1, 0 2 zeros minus 2, so 10 raised to 25 plus 1 minus 2 divided by 16 becomes 10 raised to 22 divided by 16, and when I divide 100 by 16 I will get 0.0625, and then into 10 raised to 22, that means I have divided 1 by 16 here, 1 by 16 rather, 1 by 16 I have divided, and I have got 0.0625 into 10 raised to 22, and that is 6.25 into 10 raised to 20 seconds. So that is the answer, and otherwise we can divide 1 by 16, we get 0.0625, and 0.0625 becomes 6.25 into 10 raised to minus 2. So I can take it as 6.25 into 10 raised to minus 2 into 10 raised to 22. That means minus 2 plus 22 becomes 20, and the answer is 6.25 into 10 raised to 20 seconds. Try to understand that. Now coming to the page number 44, that is example number 30. There are a few examples in this. Now to find units digit in the value of 2 raised to 224 divided by 4 raised to 32. Let us simplify this first. 2 raised to 224 divided by 4 raised to 32. I can write 4 as 2 square, so it becomes 2 raised to 64. So 2 raised to 224 divided by 2 raised to 64 is equal to 2 raised to 160. Now very interesting thing is when we take 2 raised to 1 it is 2, when I take 2 raised to 2 it is 4, when I take 2 cube it is 8, when I take 2 raised to 4 it is 6. So we have 2, 4, 8, 6 digits in its place. But when I take 2 raised to 5 again it becomes 32. That means the first digit is 2, again the fifth digit is 2. 2 raised to 6 is 64, 2 raised to 7 is 128, 2 raised to 8 is 256. That means 2, 4, 8, 6 digits, they cycle. See, the unit digits 2, 4, 8, 6 cycle every 4 steps. Now let us see, when I divide 160 by 4 it becomes 40. That means 160 is divisible by 4 and we get 40, and 160 is completely divisible by 4 with no remainder, therefore it completes the cycle. That means it completes the cycle, therefore the digit in the units place of 2 raised to 160 is 6, or 2 raised to 224 divided by 4 raised to 32 has 6 as a digit in the units place. Try to understand that. Now number of bottles in a container, 5 bottles. Every day 1 container is brought, therefore the number of bottles brought after 40 days will be 5 into 40, 200 bottles. To express the numbers as a product of 2 or more powers in 3 different ways. Now I have expressed here 64 cube can be written as 8 raised to 4 into 2 raised to 6, or 16 raised to 2 into 2 raised to 10, or 4 raised to 4 into 2 raised to 10. So if you simplify this, all these 3, I get again 64 cube, and therefore they are correct answers. Similarly, 192 raised to 8 can be written as 2 raised to 6 into 3 raised to 8, or 2 raised to 48, 8 6 are 48 into 3 raised to 8, or 2 raised to 24 into 24 raised to 8, or 8 raised to 16 into 24 raised to 8. When I simplify these, I get again 192 raised to 8, and therefore these are 3 ways of writing the given question 192 raised to 8. So try to understand this, and only try to rather raise 192 in powers of 2, and then you will get all these answers correct to 192 raised to 8. Now 32 raised to minus 5 is 2 raised to 5 raised to minus 5, and that is 2 raised to minus 25, because 32 is 2 raised to 5 raised to minus 5 becomes 2 raised to minus 25, and the further we can write 2 raised to minus 25 as 2 cube into 2 square raised to minus 5, or 2 raised to minus 5 into 4 raised to minus 5, or we can write it as 16 raised to minus 5 into 2 raised to minus 5. So there are different ways of writing it. We can follow any one of the methods. So this requires a bit of practice, and you should know how to use the correct powers, and we can express the numbers as the product of 2 or more powers in 3 different or more different ways rather. Now to examine the statements and express true or false, cube numbers are also square numbers. This is sometimes true, because 64 is 4 cube and 64 is 8 square, so definitely we can express the cube numbers as well as a square number. Now fourth powers are also square numbers. If you take 2 raised to 4, then it will be 2 square into 2 square, that is 4 into 4, therefore it is 100% a square number. Now 3 raised to 4 can be written as 3 square into 3 square, 9 into 9, and therefore fourth powers are also square numbers is 100% or always true. Now the fifth power of a number is divisible by the cube of the number. The fifth power is divisible by the cube of the number. That means if a raised to 5 is divided by a raised to 3, I get a raised to minus 5, a raised to 5 minus 3, and that is a square, and that is true. 2 raised to 5 divided by 2 raised to 3 is 2 raised to 5 minus 3, 2 square, and that is 4, therefore it is always true. The product of two cube numbers is a cube number. The product of two cube numbers is a cube number. Supposing I have a cube into b cube, then it will be a into b whole raised to cube, and it is always true, because 2 cube into 3 cube becomes 2 into 3 cube, that is 6 cube, and therefore statement is always true. Now coming to 9 raised to 46 is both a fourth power and a sixth power. It is never true, because 46 is not divisible by 4 or by 6, and therefore it is a wrong statement. Now the fifth question is to simplify and write in exponential form. 10 raised to minus 2 into 10 raised to minus 5 is add this, apply the laws of exponents there. That is a raised to m into a raised to n is a raised to m plus n, and therefore it is 10 raised to minus 2 minus 5, that is 10 raised to minus 7. Division means a raised to m minus n you have to do, therefore 5 raised to 7 minus 4, that is 5 cube. Then again division, 9 raised to minus 7 minus 4, that is 9 minus 11, and 13 minus 2 raised to minus 3 is a raised to m raised to n is amn, and therefore it will be minus 2 into minus 3, that is 13 raised to 6. And here we have m raised to 5 n raised to 12 into mn raised to 9 is m raised to 5 n raised to 12, m raised to 9 into n raised to 9, because we know that mn raised to a will be m raised to a into n raised to a, and therefore now we have m raised to 5 and m raised to 9, 5 plus 9, and n raised to 12 plus 9, and therefore the answer is m raised to 14 into n raised to 21. Remember that. Now if 12 square is 144, we have to write the answers for this. If 12 square is 144, the 1.2 square becomes 1.44, because after there is one decimal point here, so we have to put the dot after two places, so it is 1.44. Now we know that 12 square is 144, and we have to place the decimal after 4 places, therefore 1, 2, 3, 4, put a 0 and put a decimal point. Again 12 square is 144, we have to place the decimal after 6 places, put so many zeros and put decimal point. Now 120 square can be written as 12 into 10 square, or 12 square into 10 square, or 144 into 100, therefore 144 14400 is the answer for that. So just by knowing the value of 12 square, we can write the decimal squares very easily. Now question number 7, to find the numbers that are same. Now we are given here 2 raised to 4 into 3 raised to 6, 6 raised to 4 into 3 raised to 2, 6 raised to 10, 18 raised to 2 into 6 raised to 2, and 6 raised to 24. We have to identify which of these are the same. Now let us take the first case. Now both are prime numbers here, 2 is the prime and 3 is the prime, and therefore 2 raised to 4 into 3 raised to 6 remains the same. Now let us take the next number, 6 raised to 4 into 3 raised to 2. 6 is not a prime number, so therefore expressing 6 as 2 into 3 raised to 4 into 3 raised to 2, we get 2 raised to 4, 3 raised to 4 into 3 raised to 2, and 2 raised to 4, and 3 raised to 4 plus 2 becomes 3 raised to 6, so 2 raised to 4 into 3 raised to 6. So the first one and the second one 1, 6 raised to 4 is also same. Now coming to 6 raised to 10, when we take 6 raised to 10, it becomes 2 into 3 raised to 10, that is 2 raised to 10 into 3 raised to 10, which is different. Now taking 18 square into 6 square, 18 is 9 into 2 raised to square, and 6 into 6, so this is 6 here, so 6 square, and instead of writing 6 square, I can write it as 2 into 3 whole raised to square. So don't write 6 square here. 6 becomes 2 into 3 raised to 2, and therefore 9 square is 3 square raised to 2, there is 3 raised to 4, and 2 square, and this becomes 2 square into 3 square, therefore 2 raised to 4 into 3 raised to 6. Again, the 18 square into 6 square is also same as 2 raised to 4 into 3 raised to 6. Now 6 raised to 24 becomes 2 into 3 raised to 24, it is 2 raised to 24 into 3 raised to 24, it is different, and therefore the first one, the second one, and the fourth one are all the same. Okay, understand that. Now coming to the next question, question number 8. Now to find the to identify the greater number, 4 raised to 3 or 3 raised to 4, 4 raised to 3 or 4 cube is 64, 3 raised to 4 is 81, definitely 81 is greater than 64, that means 3 raised to 4 is greater than 4 raised to 3. 2 raised to 8 or 8 raised to 2, 2 raised to 8 is equal to 2 raised to is equal to 2 raised to 8, and 8 raised to 2 is 2 cube square, that is 2 raised to 6. That means 8 is 2 cube raised to 2 will become 2 raised to 6. Now definitely 2 raised to 6 is smaller than 2 raised to 8, rather 2 raised to 8 is greater than 2 raised to 6, and therefore 2 raised to 8 is greater than 8 raised to 2. Now 100 square or 2 raised to 100, it is very clearly visible to us here. 100 square is smaller than 2 raised to 100, and therefore 2 raised to 100 is greater than 100 square. Now the next question, question number 9, the milk produced is 8.5 billion packets, 8.9 into 10 raised to 9 packets rather. Now we have to, each packet must have a unique ID, and therefore the number of IDs required will be 8.9 into 10 raised to 9, so many IDs are required. Now the digits are from 0 to 9. When we use the digits 0 to 9, we can have 10 digits, because 0 to 9 gives us 10 digits, and we can have a 10 digit code, and when we use a 10 digit code, we will get 10 raised to 10, or that is 10 into 10 raised to 9. 10 into 10 raised to 9 is equal to 10 billion, is equal to 10 billion, and 10 billion is definitely greater than 8.9 into 10 raised to 9. Please understand here, 10 raised to 10 becomes 10 into 10 raised to 9, that means it is 10 billion. So if you use a 10 digit code, we get 10 billion IDs, and 8.9 into 10 raised to 9 is definitely less than 10 billion. Therefore the power of 10 raised to 10 and 10 raised to 9, if you compare, 10 raised to 10 is greater than 10 raised to 9, therefore a 10 digit code is required to number the 8.5 billion packets of milk. Remember that. Now coming to the next question, 64 is equal to 8 square, a square number, 64 is equal to 4 cube, a cube number. There are innumerable numbers that are both squares and cubes. Okay, so 64, that means the same number 64 will be a square number also and a cube number also, and there can be any number of number that are both squares and cubes. In general, if the power of a base is 6, if the power of a base number is 6, then it will be both a square number and a cube number. Please understand this. In general, if the power of a base number is 6, if the power of a base number is 6, it will both be a square number and a cube number. Let us understand this with an example. Now let us take for example 2 raised to 6. 2 raised to 6 is 2 is multiplied 6 times, and that is if I pair them, now if I take 1 pair, 2 pair, 3 pair, that means taking 1, that is 2 to the 4 to the 8, that means 8 square. That means 2 raised to 6 is 8 square, and also if I make groups of 3 here, it becomes 2 to the 4 to the 8, that means it becomes 2 to the 4, 4 cube, and therefore base is 2, power is 6, base is 2, power is 6, so 8 square is 64, 4 cube is 64, so 64 is the number which can be expressed both as a square number as well as a cube number. Let us take one more example. If I have a base as 3 and the power as 6, I will have multiples, that is 3 is multiplied 6 times here. Now if I take pairs here, 3 into 3, 3 into 3, 3 into 3, I will get 9 cube, but if I take triples there, I will get 27 square. That means 27 square is 729, 9 cube is also 729, and therefore 3 raised to 6 is 729, which can be expressed as a cube of 9 as well as a square of 27. So therefore remember, if a raised to 6 is a number, that means a is the base and its power if it is 6, then it can be written as a cube number as well as a square number. So please remember that. Now coming to the next example, the passcode of a digital locker is of length 5. The passcode of a digital locker is of length 5. The digits to make a code are alphanumeric, and to find the number of codes possible. When I say alphanumeric, that means there will be numerals as well as literals. We have got 10 numerals and 26 literal digits, or 26 literals, that means are starting from A to Z. So therefore there are total 36 digits for each window. For window 1 it is 36, in 36 ways we can fill it. Now W2, the second window in 36 ways, third window in 36 ways, fourth window in 36 ways, and fifth window in 36 ways. So the total number, total codes possible will be 36 raised to 5. So that will be the number of codes that will be possible for us to write using alphanumeric, that is letters as well as the numbers. Now coming to the next example, we have a sheep population. The sheep population is 10 raised to 9. The goat population is 10 raised to 9. Total population of goat and sheep is equal to 10 raised to 9 plus 10 raised to 9. That is 2 into 10 raised to 9 is the answer. Now coming to the 13th question, world population is 8 into 10 raised to 9, almost 8 billion. The clothing per person is 30 pieces of cloth, and therefore the total number of pieces of clothing will be 8 into 10 raised to 9, that is the population, into 30 pieces, and that is 8 is 24, 240 into 10 raised to 9, or 2.4 into 10 raised to 11 clothings. So their total clothing will be required. Now coming to the next question, that is 13th question, number of bee colonies 100 million, and that is 100 into 10 raised to 6, and number of bees in each colony will be 50,000. Therefore the total number of honey bees will be the total number of colonies into number of bees in each colony, that is 100 into 10 raised to 6 into 50,000, and that becomes 5 is 5 into 10 raised to 6 into 10 raised to 6, and that is 5 into 10 raised to 12 bees. Remember that. Now bacterial cells in human being or in one human body are approximately 38 trillions, that is 38 into 10 raised to 12. The world population is approximately 8 billion, therefore bacterial population will be the number of bacteria per human being into the population of human being, that is 8 billion. So 38 into 10 raised to 2 into 8 into 10 raised to 9, therefore 38 into 8 into 10 raised to 12, that is 10 raised to 12 into 10 raised to 9. This is 10 raised to 12 here, 10 raised to 12 into 10 raised to 9, and that will be 304. When I multiply, you get 304 into 10 raised to 21, or 3.04 into 10 raised to 23. So please make a correction here, it is not 10 raised to 2, it is 10 raised to 12. Now coming to the next question, eating time per day for one individual is 1 hour. That means it comes to so many seconds, that is 3.6 into 10 raised to 3 seconds, and a person generally lives for 70 years. Therefore the total eating time will be 70, that is 70 years can be converted to seconds, and that will be 70 into 365 into 24 into 60 into 60 seconds, that is 1.61 into 10 raised to 11 seconds, and the total time spent in eating will be the 1 hour, that is 1 hour per day into 70 years, and that will be 3.6 into 10 raised to 3 into 1.61 into 10 raised to 11, that is 8.7 into 10 raised to 14. Okay, 8.7 into 10 raised to 14 seconds. So these were a few examples on the basis of exponential notation, or applying the basics and the properties of exponential notation in solving the examples. The examples are easy, but you have to understand how to use the exponential notation. Please learn them, practice them, note them in a book, and keep it as for a future reference. Okay, thank you.